Live. What is up, everybody, for Data on Kubernetes live stream number 127, 128. We're getting close to 130. Very, very good to be here for our second live stream this week. As you know, we have our upcoming events in KubeCon, DoK Day. All right, so I'm just going to drop the link. I'm going to drop the link here in the chat. So if you haven't signed up already, you can do so. All right, I'm going to drop the link right there. So please, please, please make sure that you sign up. It's totally free. All right, it's virtual. It's going to be awesome. We're going to have live music. We're going to have prizes, swag, quizzes, all that kind of good stuff. If you are going to be on site in Valencia on the day of the event on May 16th, and you're going to be in the area, please let us know because we will be doing an after party with some really, really good live music, and we're going to have a good time. The weather will be good. That being said, very excited about today's talk. In the promo, I asked, is it secret? Is it safe? I am a Lord of the Rings fan, and I appreciate any opportunity I get to drop some Lord of the Rings stuff. So we are today with Kim Schlesinger, who is a developer advocate at DigitalOcean. Kim, welcome to the Data on Kubernetes community.
Hi, thanks so much for having me. I'm excited to be here.
Yes, good. First question, you're a cyclist, or are you a cyclist?
I am. That's my mountain bike back there. So
Nice.
I live in Denver, Colorado in the USA. And so there are mountains I can go to and cycle. And I got into mountain biking and like gravel biking during the pandemic as a way to get outside and be safe.
The gravel biking and being safe, those things go together.
I'm like a very cautious person, so you'll see me hop off my bike a lot or go really slow.
Okay, that's good. So you enjoy with a certain margin of caution. That's good.
Yes, absolutely.
All right. So anyway, looking forward to the talk today, but can you just tell us a little bit about yourself, how you got involved in the Kubernetes world, et cetera?
Yeah, so I am currently a developer advocate at DigitalOcean, and I think my actual title is Cloud Native Developer Advocate, but really what I do is give talks about Kubernetes and show off DigitalOcean's managed Kubernetes offering. Before DigitalOcean, I was a site reliability engineer at this company called Fairwinds. Fairwinds does consulting, and they have software as a service for like container scanning and security stuff. But I was on the services team, so I got to work with companies that hired us to build out Kubernetes clusters, build out CI/CD pipelines, and then teach their employees how to deploy application changes in their Kubernetes cluster. So that was an interesting job just because I think it's kind of unusual for people who work with Kubernetes to get to look into and work with different Kubernetes clusters and see different setups and see different use cases. So I did that for 3 years. And before that, I was a teacher. So I taught primary school for about 6 years. And then I switched into adult education. And eventually I went to a software coding boot camp where I got trained in tech.
That's amazing. All right. And I think also it's interesting enough that today you're going to be teaching us. So this is something, it's not anything new for you. And to see the nice, different transition of skills that can work in all these different areas. Mm-hmm. And working in primary school for 6 years, I did it not for that long, but I once was a teacher as well.
Nice.
And I think it's something everyone should do, or at least shadow a teacher for a day to understand how difficult it is, the patience that's necessary, the passion and empathy. Yeah,
I agree. I think everyone should, you don't have to do anything, but you should just sit in the back of a classroom for a day. And it's tough. It's a really, really tough job.
And everybody out there, if you have the ability to pay your teachers more, do so because they need to be better paid. They're never overpaid. All right. Don't buy into this. Oh, they get 3 months of summer vacation. That is nonsense. My partner is a teacher and it's not the case. So anyway, support your teachers out there. That being said, I'm going to let you start sharing your screen. You've got a repo that I'm going to be sharing here
Thank you.
in the chat. So if you want to follow along with that while Kim's explaining, and of course, folks, if you have any questions, please put them in the YouTube chat. We'll get them answered accordingly. But that being said, if you want to start sharing your screen, you can go for it.
Yes.
Okay.
All right. And I have to do that thing. You can see my screen?
Yes.
Sorry,
like tally marks on the wall.
Exactly.
Okay, cool. Let's do it.
Super. Well, welcome. This talk is called Getting Started with the Kubernetes Secrets Store CSI Driver. And I'm Kim Schlesinger. I already sort of gave you the introduction about myself. But I'm really excited to be part of the DoK community and to give this talk. When I came up learning Kubernetes like 4 years ago, the prevailing wisdom at the time was never run any stateful workloads inside your Kubernetes cluster. And the exciting thing is that like Kubernetes and the CNCF and all these different projects have evolved in such a way that it's a lot safer and like it makes more sense to run stateful stuff in your Kubernetes cluster. So I'm learning a lot, and I learned a lot by prepping this talk. So thanks for having me. So we're going to do 3 things today. So the first thing I'm going to do is just define a couple of key terms that's going to help us understand what we're doing. Then I'm going to do a demo showing you how to use the Kubernetes Secrets Store CSI Driver with Hashicore Vault. And then at the end, I'll leave some time for question and answers. If you don't already know, you're welcome to drop questions in the chat, and Bart will ask those to me when it's a good time.
Absolutely.
So let's hop in and talk about the key terms, like the vocabulary that you need to understand in order to follow along with this talk. So the big key term that I want you to walk away with knowing today is ephemeral volumes. And so in Kubernetes, we know about persistent volumes and persistent value claims. And in Kubernetes 1.19, we get this new thing called ephemeral volumes. And so these volumes are not persistent, and they have the same life cycle as a pod. So when a pod gets created, the ephemeral volume gets created. When a pod gets deleted, that volume gets deleted. And the ephemeral volume, it sticks with whatever pod it's supposed to be with. Ephemeral volumes are really good for storing read-only data. And that kind of data is stuff like secrets. So if you have API tokens that your application needs, or usernames and passwords to connect with a database, or those sort of credentials that need to be secret and only need to be read by your container, ephemeral volumes are really good for that particular use case. So ephemeral volumes came out of SIG CSI, the Container Storage Interface working group, where they're working on building out the ecosystem of storage plugins for Kubernetes. And it became widely available, general availability, the ephemeral volumes in Kubernetes version 1.19. So if you're following along with this, this demo that I'm going to do, you want to make sure that you're running at least Kubernetes version 1.19 or greater. So there are 2 different kinds of ephemeral volumes. The first one is the CSI ephemeral volume, and the second one is the generic ephemeral volume. And they're very similar, but if you look at those red X's, there's a couple of things that make them different. So let's just go through this list. So both the CSI ephemeral volumes and generic ephemeral volumes, they follow the pod life cycle. So like I mentioned before, they get created and destroyed with pods. The next thing that they both have is you can create those ephemeral volumes through an inline definition. And I love this part. So in your pod spec or in your deployment manifest, you can specify that you want an ephemeral volume to be created when that pod is being created. And it's nice because you don't have to have anything separate like a persistent volume or a persistent volume claim. Here's where we're getting into the differences. So CSI ephemeral volumes, you cannot specify what kind of storage class Kubernetes is going to use for that volume. I think the driver handles that. But if you're using generic ephemeral volumes, you can specify the storage class. And then finally, the CSI ephemeral volume, it uses a third-party driver, and then the generic ephemeral volumes don't. So that's a lot of theory. If you're not quite sure what all that means, no problem. The thing that you need to know about ephemeral volumes is that they get spun up and down with pods, and you can define them inside a YAML manifest. So those are the ephemeral volume types. That's the only key term that I want you to know is ephemeral volumes. And I'm going to be showing you how to use the Secrets Store CSI Driver with Hashicore Vault. So we're going to hop into that right now. So we'll get into the demo. I will minimize this. And Bart has shared this repo that I've put together. And so we'll just kind of do a quick look at what's located in this repo, and then we'll start on the demo. So this is my personal GitHub. This is just a little introduction. It's like the text from the meetup advertisement. And then I have resources here. There are slides. So the slides that I just showed get rendered through Markdown, and then there's the license. But the thing that you really want is the tutorial. So this is the step-by-step instructions of what I'm about to do. And if you're curious, we're going to be running some commands and creating some Kubernetes resources from these YAML manifests. We'll have to dig into these a little bit, but these are here. Uh-oh, something's wrong there. That's okay. We'll figure it out as we go. So time to do the demo. I'm really excited. So go to the tutorial. Beautiful. And the first thing that we need to do is to make sure that you have a Kubernetes cluster up and running. So I created this Kubernetes cluster using DigitalOcean, and it's called Data on Kubernetes Talk. And I need to get the kubeconfig downloaded on my machine so I can use kubecontrol to interact with this cluster. This is a nice command. Doctal is the DigitalOcean command line tool. So beautiful. And I just want to make sure I can actually connect to the cluster. I'm going to say kubecontrol get nodes. Excellent. So I have a cluster that's running 3 worker nodes. I'm using Kubernetes version 1.22.8, and you can see I spun this cluster up about 25 minutes ago. So we are good to go there. Next thing I'm going to do is I'm going to create a namespace where I'm going to have all of these things installed, and I'm going to call that namespace demo. So I'm actually going to bump up the size of this real fast, and we'll say, okay, I want to create kubecontrol, create namespace demo. And I just want to verify that was created. So kubecontrol get namespaces. All right, so I have this demo namespace. That's where I'm going to install Vault. That's where I'm going to install the CSI driver. That's where I'm going to deploy the application that's going to get secrets from those things. So we're ready to go there. We've got some nice namespace isolation for this particular demo. All right, back to the tutorial. All right, so step 1 is prepare your cluster. I did that. I can connect to my cluster. I have a namespace called demo. And then the second thing that we're going to do is we're going to set up Hashicorp Vault. So Hashicore Vault is a really popular project. It's an external secrets store. So it's this software that runs on its own where you can store secrets and then gather the secrets from all sorts of different places. You can use Vault to get secrets into Kubernetes, but you can also use Vault with all sorts of other different kinds of platforms and programs. So what I'm going to show you now is I'm going to install this Vault instance inside the Kubernetes cluster that I've got up and running. I'm going to be doing it in dev mode. And as a note, this is something you shouldn't do for production. You can run Hashicore Vault externally and then connect it with your Kubernetes cluster. That's like the best thing to do. During the demo, you're going to see me do things like accessing the Vault, manipulating data in the Vault, and you can actually like see the passwords and the tokens. And so if somebody gets access to your Kubernetes cluster and they have the right credentials and your Vault is in there, like your secrets aren't very secret. So I'm running Vault in the Kubernetes cluster in developer mode for demonstration purposes only. So keep that in mind if you are thinking about doing this in production.
Real quick question. Sorry,
go for it, Bart.
We got a question from Sergey. Can ephemeral volumes be associated with namespaces and their life cycle?
Oh, that's so interesting. I don't think so. I think they are only affiliated with pods and the pod life cycle. And so, yeah, the ephemeral volume gets spun up and down. If you wanted to, I think I see what you're asking. Like, could it be like a persistent volume for a namespace or something like that? The answer is no. It's related to the pod.
Awesome. Thank you.
Cool. All right, so I gave the disclaimer about Hashicore Vault and how I'm running it in this talk, and let's get started and set it up. So I'm using Helm to install and manage Hashicore Vault. So the first thing that I need to do is I need to add the Hashicore Helm repo to my local Helm repos on my computer. And I'm pretty sure I already have this installed because I've been prepping this talk, but let's make sure. So I'm running Helm repo add Hashicore, and then I'm giving the URL of the Hashicore Helm chart. So it says Hashicore already exists. Now I want to make sure that I have the most updated version of that repo. So I'm going to say Helm repo update Hashicore. All right, looks good. And then here we are. We're going to install a dev server instance of Hashicore Vault inside the demo namespace. So a note here, like I just mentioned, if you're interested in running Vault externally, Hashicore has a great guide about how to do that. So I would click here if that's something you're interested in doing. So let's look through this though. I'm going to install the Vault inside my Kubernetes cluster internally. And so I'm saying helm install Vault in the namespace demo. And then I'm enabling these 3 different options. So the first thing I'm saying is I want this to be in development mode. So that's server dev enabled true. And then I don't want the secrets injector enabled because we're not using that particular feature. And then I do want to enable the CSI and ephemeral volumes so that Hashicore Vault can talk with the ephemeral volumes that we're going to spin up with our pods. So making sure all of those things are set. So I'm just going to copy this command. And we're going to run it here. And we'll give that just a moment. Great. So we've got this message from Helm. It says, hey, I created this Helm release called Vault. It's in your demo namespace. And then Hashicore leaves us a nice message like, hey, here are the Vault docs if you want to check them out. So let's just see what got created with that. So if we say kube control, get pods, namespace demo. Right, so we see 4 different pods are running. We have this pod called Vault 0. That's the actual Vault server running. And then we have this Vault CSI provider, and we've got 3 different replicas of it. So those are created by a daemon set. And so just making sure that we can use the CSI driver with our Vault instance. So looks like we're good to go on the installation there. And so the next 2 steps that we're going to do, we're going to store a credential inside of the Vault instance. And then we're going to set up the Vault instance to be able to interact with our Kubernetes cluster and talk with the pods that we're going to create. So let's go on to step 3. So store a credential using Vault's key value storage. So the first thing that I'm going to do is I'm going to exec into that Vault pod. So saying kube control, exec into that pod, the namespace is demo. You want an interactive terminal, that's -it, and then you want to have access to the shell. So excellent. So you see the command prompt changed. So I'm actually inside that Vault pod and I have access to that. So if we just like look around, these are all the directories inside the pod. And then it comes with this Vault executable ready to go. So you can see all the different commands that you can use with the Vault. I also like this other command section, which are maybe less used commands, but still important. And so what we're going to do is we want to store a key value pair in the KV engine inside of this server. So let's clear this out and let's see how you do that. All right. So in this demo, I am storing an API token, and then I'm going to deploy an application that's going to need access to that API token to do something important in order for the application to be up and running in the way that I want. And so the first place that we're going to store that secret information is inside Vault. And so this is the command I'm going to run. I'm saying Vault and then KV for the key value engine. And I'm going to put this secret token, and then I'm actually giving it the key and the value. So the key is token and the value is this string here. So this particular path, secret token, is important. And so just keep that in mind. We'll see it in just a minute. But let's run that. Let's put this token inside of the Vault key value engine. Okay, so we've got key value, gives us a timestamp. If there's any metadata, I don't have any. When was it deleted? Has it been destroyed? And has it been updated? So that was just my first instance of the key value pair. And then if you want to see that data in Vault, you say Vault key value get secret token. And so let's take a look at that. All right, so we get the same metadata that we just saw, but now we actually see the data. And so this is a great example of why you don't want to run Vault in your Kubernetes cluster. Like someone can just exec into it and see the data. So keep that in mind. All right. So back to the tutorial. So what we just did was we stored a credential using Vault's key value storage. And so let's go on to the next part, and then we'll do a little review of what we've done with Vault. So the next thing that we're going to do is we're going to make sure that Vault can access and do things inside of the Kubernetes cluster, because we want that API token credential to be shared with a pod eventually, but we have to do some setup there. So the first thing that we're going to do is we're going to enable Kubernetes Off inside of Vault. And so it's Vault Off enable Kubernetes. So I'm still in the Vault pod here. So Vault Off enable Kubernetes. All right, it says success enabled Kubernetes Off method at the Kubernetes path. All right. And now we get into some more complicated things. So what this next command is going to do is it's going to set up the proper configuration for Vault to authenticate in the Kubernetes cluster. And so the way that we do that is we create a file in this path, auth Kubernetes config, and then we're pointing to all these things. So the issuer, we're saying the cluster that we're in is going to be the certificate issuer. There's a token for access that Kubernetes created that we're going to grab. The Kubernetes host, the address, and then pointing to where the certificate authority cert is inside the Kubernetes cluster. So I'm going to grab that command, paste it in here. It says success data written off Kubernetes config. All right. And then the next thing that we're going to do now that we've got Kubernetes authentication set up in the Vault server is that we're going to create a policy, and we're going to call it app permissions. And it's going to allow the Secrets Store CSI Driver to read the mounts and the secret itself. And so there's that transfer of data here. And so we're just saying, hey, I'm creating a policy. It's called app permissions. That policy has access to that path where my token data is stored. And the only thing I want it to be able to do is read. There's no like edit, write, or destroy permissions here. So we just want it to be able to read the data. So clear this. Excellent. So it says uploaded policy. We have this new policy called app permissions. All right, next part, we're creating an authentication role called database that's going to bind that policy that we just created saying, hey, whoever has this policy is able to read that token data. And so we're going to connect that policy with a service account in Kubernetes that we're going to call the app SA or the app service account. And so you see we're writing a role here. It's called database. And we're saying, hey, the service account you're going to be linked to is called app SA. And this is all going to happen in the demo namespace. The policy that you've got is app permissions, and the TTL is, looks like 20 minutes. So we'll copy this. All right, looks like we've got that role up and running. And so we've like configured our Vault instance. So I'm going to exit out of that pod. Beautiful. And then let's just do a quick review. That's a ton of stuff. So what have we done? We have created a cluster. We've connected to the cluster. We installed Hashicore Vault, and we have a Vault server running inside the cluster, inside our demo namespace. We did that with Helm. And then we actually got into the Vault server and we stored that API token inside the Vault. And then we set up Vault so it has the permissions it needs and all the access and the configuration to be able to communicate and work inside the Kubernetes cluster. And then we exited out. So I'll pause there and see, are there any questions, Bart?
Sorry, looks like we're pretty good.
All right.
Yeah, looks like we're good.
Cool. All right, so we've got Vault set up inside our Kubernetes cluster, and the next thing that we're going to do is we're going to set up the Secrets Store CSI Driver. So let's actually look at that that set of docs. So, all right, so in the resources. So this is the official Secrets Store CSI Driver docs. This project is part of the CSI SIG. And so it gives us lots of information here. They're really good docs. I use them to prepare this talk. But yeah, it looks like here. And yeah, we'll get started. So actually, before I get started, so one thing I want to point out is if you're going to use the Secrets Store CSI driver and you want to create ephemeral volumes with a pod, you have choices about the external secret store that you use. So in this demo, I'm using the Vault provider. Vault's an open source project. It's through Hashicorp, and DigitalOcean doesn't have like a secrets management product like other bigger clouds do. So if Vault isn't right for you, or you're running your cluster on these other clouds, then I would check out these providers. So there's an AWS provider, there's an Azure provider, and there's a GCP provider. So like we look at that, it's going to take us beautiful to another project that AWS hosts that allows their secrets storage product to interact with the CSI driver. So instead of Vault, that's what you would be setting up. And then just so you can see, the Vault provider has its own documentation here. Yeah, and it's good. You can see some of the commands that we've already run. So just to note there's choices for the external secret provider. All right, so let's do this. So the first thing we're going to do is we're going to install the Secrets Store CSI driver. Using Helm, we're going to add the Secrets Store CSI driver repo to our local Helm repos. Once again, I think I already have this installed. Yep, looks like it's good. And then we're going to update that repo. So Helm repo update Secrets Store CSI driver. Make sure we have the most updated version of the software. Cool. And then we're going to create a Helm release in our Kubernetes cluster so that the CSI driver is running. So we're going to be running this Helm installation command. And so we're just saying, hey, I want you to create a release called CSI Secrets Store. You're grabbing it from the Secrets Store CSI driver repo and then the Secrets Store CSI driver Helm chart. We're doing this in the namespace demo. And then this next flag is really important. I'm saying I want secret sync to be enabled. And so the very last thing that we're going to do in the tutorial is we're going to get the API token that we stored in Vault. We're going to store it as a Kubernetes secret, and then our application will be able to get that, that data from the Kubernetes secret. And so you have to have secret sync enabled in order to do that. So I'm going to grab this command, I'm going to create that Helm release. And it takes a little while. Excellent. So we get this message from Helm. That release was deployed. Give us some information about how to check that the deployment worked. So let's look at the pods in the demo namespace. All right, so we've got 3 new pods. It makes me think it's controlled by a daemon set as well, but it looks like on every node we have this set of pods running to enable that third-party driver so that we can have those ephemeral volumes connected to our pods, and then we can also talk with Hashicorp Vault. So looks like we are good to go there. All right, so we installed the Secrets Store CSI driver. And now we're getting into like the application part of it. We're going to create some Kubernetes objects so that an application can use the CSI driver and create that ephemeral volume that stores the API token secret. So the CSI driver creates a custom resource that's called a secret provider class. And so let's take a look at that in our, I'm going to do it in here. So in the manifest directory, there's a secret provider class YAML file. And you can see I messed up here and I deleted some stuff and then pushed it up to the repo. So let me Command Z a little bit here. Perfect. Okay. So we're going to uncomment those things out later. I'll fix that repo after the talk. But here is our custom resource. It's called a secret provider class. And if you see in the spec here, you get to specify which provider you're using. So that list of providers that we saw, I'm using Vault. If you were using the AWS provider or the Azure provider or the GCP provider, this is where you would specify it and then put in the relevant parameters. And so I'm using Vault, and my Vault address is inside the demo namespace. It's called Vault, and it's using port 8200. And then we see the role name. So that's from Hashicore Vault, where we created that Kubernetes role and then applied the policy and then connected the policy with a service account. And then
sorry, we got another question.
Oh yeah, go for it.
So what is the best practice to install Hashicore Vault, like inside K8s, outside K8s clusters?
That's a good question. I would say outside K8s cluster. I would run it externally, like on a virtual machine that's not part of your Kubernetes cluster. That way you just have like that big separation of concerns that if somebody had access to your Kubernetes cluster, they wouldn't be able to exec into the Vault pod and like get your data. So I would definitely recommend running Vault externally.
Okay, perfect. Thank you.
Yeah, you're welcome. So yeah, this is the custom resource, the secret provider class that the CSI driver installed inside our Kubernetes cluster. And so we need to actually create this. So just to prove that I'm creating something, let's see, do we have any secret provider classes in our demo namespace? So if I say kubectl get secret provider class in the namespace demo, says I don't have any of those in the demo namespace. So let's fix that. Let's create one. So we're going to say kubectl apply the file. It's in the manifest directory and it's called secret provider class.yaml. Excellent. So it says I created a secret provider class called Vault database, and let's see if we've got that. All right, so you see that secret provider class was created in that namespace. It's running now. So that the namespace is aware of Vault. All right, the next Kubernetes resource that we need to create is a service account. And so let's look, we've got a YAML manifest for that. Very simple. So we're just creating a service account that's called app SA, app service account in the demo namespace. And we need that for Vault to be configured properly. So let's create that. We'll say kubectl apply the file in the manifest directory called service account. Excellent. And then if we say kubectl get service accounts from the namespace demo, see we've got some other service accounts in there, but I just created this one. And then the last thing that I want to do is I actually want to create a pod that's running an application. And so we're going to create a deployment that mounts a CSI ephemeral volume to your pod. So this is where those ephemeral volumes come into play, where when I spin up the pod, the ephemeral volume gets created with the pod. When the pod gets terminated or destroyed, the ephemeral volume goes with it. So let's take a look at this deployment YAML. All right. So first thing is, this is actually a pod, not a deployment. I'm hoping to change this later on, but if you have like a real keen eye for detail, I know. So it's not a deployment, it's a single pod, and I will change this to a deployment eventually. So, all right, so this is our pod spec. We are going to create a container in this pod using the Busybox image, and we're just going to make sure that Busybox is always spinning. We want to be able to exec into this container so we can see if we can find the secret, set some resource requests and limits, and then here's how we're specifying the ephemeral volume. So we have this volume mount. And so we're saying, hey, I want access to the Vault database, that secret provider class thing. It's going to be mounted at this path, mount Secrets Store, and it's read only. I don't want you to be able to write anything to that. And then the volumes, we're going to create a volume called Vault database, and we're using the CSI driver. The Secrets Store is the CSI driver we're using. Read only, and then where are we getting the secrets from? From this Vault database. So let's create this pod, and then we'll look in the pod and see what we can find. So kubectl create file manifest, and then I called it deployment, even though it's a pod. Awesome. So if we get pods from the demo namespace, all right, we have Busybox up and running, looking good. Let's just describe this pod and see what evidence we can find of the ephemeral volume. So kube control, actually, let me clear out the terminal real fast. Kube control, describe the pod Busybox in the namespace demo. All right. Okay, cool. So a few things here. This looks a lot like the manifest, but it's got some additional information like what node this pod lives on and the timestamp and its IP address. But this looks familiar to me, the image, the Busybox container, the command. And then if we look down here, we see where the Vault database gets mounted. So that mount Secrets Store, as well as where the service account information is stored in the file system. And then this is my favorite part. Under volumes, we've got this CSI ephemeral volume running called Vault database. So remember, there are two types of ephemeral volumes. There's the generic ephemeral volumes and the secret, or the CSI ephemeral volumes. And so we're getting told, hey, this is a CSI ephemeral volume. If we're using generic volumes, I assume it would say generic, the driver, and then some information about it. So that's pretty cool. So we've got this ephemeral volume up and running. But the whole point of this exercise is that we want to get the secret stored in Vault and have it available to the application. And so let's see how we do that. So we just set up the CSI driver. We just created a secret class provider, a service account, and then an actual pod that's running the application. And the last part, the best part, is that we want to be able to sync that data from Vault, so the API token. We want to store it as a Kubernetes secret. And then we want our application to be able to access the data, the API token, through the Kubernetes secret. And so let's look at what we've got so far in our namespace. So just for demonstration purposes, so let's see what secrets currently exist in the demo namespace. Right, so we've got several secrets. They look like, okay, some are generated by Helm. Looks like the CSI provider token, a lot of tokens here. I want to create a secret that my application can read. So we're going to create a secret in just a moment. So first thing that we want to do is we have to add some information to the secret provider class, and it's called secret objects. So we go back to the secrets provider class, and this is the block that you need. And so I'm going to uncomment this out. And so what I'm saying is, hey, I want you to create a secret called KV secret-1. And so when I run this command after I apply this, I want to be able to see that secret in the demo namespace. And then you specify the secret type. We're going to say this one's just opaque. And then you're saying, hey, you're going to get something called token, and the key is token. And so then the secret will store the value, that string of letters and numbers. So first thing I needed to do in order to sync my Vault data as a Kubernetes secret was to add this secret objects block in the secret provider class. So let's update the secret provider class. So kube control apply manifest secret provider class. We should get a message that, yep, it looks like that was updated. Okay, cool. So we have the secret objects there. Oh, and do I have a secret yet? Kube control, get secrets, namespace demo. So that secret's called KV Vault-1. It's not here. So we got some other things to do. So the next thing I need to do is I need to configure my container to be able to get a secret as an environment variable. And so if I go to the deployment manifest, which is here. And so what I'm going to do is I'm just going to uncomment out these lines. And so what I want is I want my container to have an environment variable called API token, and it's going to get the value of, it's going to store the value of that by going to the KV secret-1 and then grab the value from the token. And so just to prove that this doesn't exist yet, let's exec into that Busybox pod. So that's my application. So kube control, get pods, namespace demo. Okay. So I want to kube control exec IT into the Busybox pod in the namespace demo. All right. And I'm looking for API token as an environment variable. So if I say echo API token, it's like, we don't have anything stored for that. Cool, that's all right. So we're going to try and make that environment variable. I don't need to update the service account, so I'm not going to worry about that. So this is where I would rather have a deployment than a pod. So I'm going to apply the deployment YAML spec, but I'm going to get an error, but we'll fix that. No problem. Yep, so it's saying, hey, I can't update the pod in the way that you want. That's why deployments are better than pods. So I'm going to delete the Busybox pod and then reapply the manifest. And we wait. Almost there. All right, so the pod's still terminating. All right, there we go. So I'm gonna recreate the pod. I added the environment variable. And so I just created the pod. Before that, there was no secret. Let's see if the secret was created. So kube control gets secrets from the demo namespace. Hey, look at that. So when I created the pod, the ephemeral volume was spun up, and then we have secret sync enabled. And so when the pod gets spun up, we get that secret created. And so when the pod is terminated, the secret goes with it, which I think is really cool. So it's like ephemeral volumes creating like kind of ephemeral secrets in that they follow the pod lifecycle. So I have the secret now, and now I want to know, hey, does my application have access to the API token? So let's exec back into the pod. And if we echo API token, hey, there's the value. All right. So yay, I mean, that's exciting. We did this complicated thing, and now our application has access to a secret that was stored in Vault. And so some of the benefits of, so instead of like coding that secret by hand, so if you're doing that, you might have to use something like Secrets Store or SOPs where you encrypt a secret and then you maybe push it to Git, and you have to have like a key management service on the other end. The nice thing about using something like Vault is that that secret can get updated through Vault, and then all of those changes will flow down, and you'll be able to get the updated secret that way. So one of the benefits of Vault. So let's, excellent. So let's go back. It says exit out of the Busybox pod and then pat yourself on the back. You're done. Oh, did I just exit out of my terminal? I guess that's okay. All right. So that is the tutorial. Let's do a quick review of what we did, and then we'll do some Q&A, and then we can be done. So, so this is data on Kubernetes, the community, and I wanted to, explore something in Kubernetes that used volumes that I hadn't before. And so I selected this Kubernetes Secrets Store CSI Driver. And so let's get the slide deck back up. All right, so what we talked about was this idea of ephemeral volumes, which is relatively new in Kubernetes. These are volumes that match the life cycle of a pod, that get mounted onto a pod and get destroyed with a pod. They have benefits for if you just want to get read-only data, they're great for that. And they're not persistent volumes, and you don't need to do a PBC. You can just specify the ephemeral volume inside your pod or deployment spec. So there are two different kinds of ephemeral volumes. There's the CSI ephemeral volume, which we showed off today, and then the generic ephemeral volumes. You would want to use generic ephemeral volumes if you wanted to specify the storage class. And you would not want to use generic ephemeral volumes if you wanted to use a third-party driver. That's what CSI ephemeral volumes are for. So we went through step-by-step how to use Hashicore Vault, where you can store secret credentials, and then setting up the Kubernetes Secrets Store CSI Driver so that it can connect with Hashicore Vault and then stores the secrets in those ephemeral volumes. And then the last thing we did was we synced that data with an actual Kubernetes secret, and then set up our application so it could access that data through an environment variable. So we did the demo, and now it's time for some Q&A if there are any questions.
Good. Well, first and foremost, thank you. This was fantastic, and
yeah,
it very much shows that you are a seasoned veteran as a teacher.
Thank you.
What I would like to ask is something that you actually mentioned in the beginning, is that you were talking about how 4 years ago when you started on your Kubernetes journey, about how like the notion of running stateful workloads is like, whoa, this is, you just don't do that, do everything statelessly. And this has been a recurring theme, obviously, in our community that's focused on stateful workloads. And people talk about things that have come along the way that have made it easier, and you touched on some of them going forward, and not to be predicting the future, but based on what we see happening right now, the vast majority of organizations that we interviewed in our survey, over 90% said that they think that Kubernetes is ready for stateful workloads. What is it you think that might be preventing more organizations from doing it, despite the fact that they openly admit that they do think it's ready?
Oh, that's such a good question. So you're asking, even though we sort of see that people believe Kubernetes is ready, in practice, we still see organizations sort of slow to adopt, running data in Kubernetes.
Yeah.
Yeah, I think it's that sort of one-liner that I was taught, never run stateful workloads in Kubernetes. I think a lot of us took that really seriously, and the stories we told ourselves about what can happen to your data if you do a Kubernetes upgrade and you don't do it quite right? Do you obliterate all of that data inside of your cluster? So I think we were sufficiently scared. And so I think it's the sort of attitude, it's getting folks in those organizations that are resistant to that kind of change to try out the new tools and to see how far the data on Kubernetes ecosystem has moved. And I think, I know Bart and I met a few months ago to talk about the community. I think this community is really cool because it's a lot of people who are younger and who are new, but part of this cloud native generation who don't have that particular attitude about stateful workloads in Kubernetes. So I think, inviting the voices of people who are maybe newer to Kubernetes and more open to running data inside of a cluster. So
that's actually a really good point. And that's something we see because we have a group of very active young folks that are in our community, and they don't come in with, like you said, those sort of biases or, I was always told you can do it this way. And so this sort of fresh start means that you don't have to unlearn, what you've learned. And once again, as a teacher, you can understand this. So I think, no, those are all good points. From your perspective, though, in the technical sense, when it came to starting to, to run stateful workloads on Kubernetes, what are some things that you found challenging, and the advice that you might be able to give, say, before you get into this, or I found this to be particularly challenging, anything like that in your experience?
Well, I'm a little bit of a hypocrite based on what I just said. I have not run any, except for what I just showed you. I have not spent time running stateful workloads in Kubernetes. I've spun up MySQL or Mongo inside a Kubernetes cluster and played with it, but I have no production experience with that. So
that's totally fine. And on top of that, I highly appreciate your honesty, because a lot of people would be like, well, it was just yesterday that I was plowing through, I've been doing this for 15 years. Anyway, that's okay. But I guess having said that, were there things that kind of surprised you along the way, or that may have been a little bit trickier than you expected? Anything like that?
Well, I think even the development of the CSI SIG, that's relatively new. So I think it can be, the Kubernetes, the ecosystem and all of the tools and all of the techniques and just how fast Kubernetes moves can be really intimidating. So I think that's a barrier for me, is just taking some time to focus on that particular part of Kubernetes. But the other thing, though, is I do now that I know a little bit more about the CNCF and how Kubernetes operates as an open source project, like there's so many people working on the project. There's so many people working on ancillary projects, like, and like the platform has developed so much in the last couple of years. Like I do trust that the data component parts are like moving in the right direction. So yeah.
Okay. No, that works. And I think a lot of people would agree that the vastness of Kubernetes as well as the CNCF, common topic is the landscape, just seeing the mass amount of projects and starting to navigate.
Yeah,
that.
The landscape is intimidating.
It is. The good news is that you don't have to know absolutely everything. I mean, nobody does. Like even, Chris Andisek, the CTO of the CNCF, he's like, I don't know everything. How could I? Like you need multiple lifetimes to be able to break that down. So I think that's kind of thing is, start with something, enjoy the process, don't be in a hurry, and use the support network of really helpful people that are there, as well as documentation, some of the things that you were referring to during the talk. So I think all those points are good.
Yeah, can I
yes.
make a plug for you? So the data on Kubernetes, first of all, the community is really cool. You have a nice active Slack workspace that I really appreciate. And just the amount of like content that you are shepherding into the world is really impressive. Like I think you did 3 talks this week.
Yeah. Next week's going to be the same. But I thank you for that. And I think that we really have taken it to heart that precisely because of what you said, that when so many people have been told that things are done in a certain way, how many times does a message need to be repeated again and again and shown in different ways for practitioners from all over the world with different backgrounds, different use cases, different end users. And that's what gives the strength and credibility that's necessary to make it more comfortable for folks in the future to be doing this. So anyway, much appreciated. Yeah. Any other plugs you'd like to throw out before we
Well, I will be at KubeCon EU and I'm coming to DoK Day. So come say hey. I'll have t-shirts and stickers, and DigitalOcean has great swag. So I would love to give you some and say hey. So looking forward to meeting some of you in person and interacting with more of you virtually.
Absolutely. Also looking forward to that. Before we finish though, can I get you to stop sharing your screen so I can share mine?
Yes.
Because as is tradition in our community, one of the things that makes us unique is that while you're talking, we have a wonderful person who's behind the scenes. His name is Angel, and he's a very talented artist.
Oh my gosh.
Artistic depiction. And he caught
so cool.
he's got a very quick eye, so he caught I'm sure the first thing he drew was probably the bicycle, and then everything was built up.
Oh, there's a bike. Oh my gosh. Oh my gosh, anyway, this is amazing.
Cool, good. No, I'm glad you. But this is the thing is that knowledge sharing is something to be celebrated, and so we're really, really happy to do this because also sometimes these concepts aren't necessarily the most tangible, and we find that celebrating the talks through art gives it a different kind of flavor. So anyway, we will see each other in Spain in
that's right.
Very short period of time.
Sooner than I care to know.
You will have jet lag. I will not. But,
that's right.
But looking forward to it. Kim, this is a fantastic talk. I can't wait to get you back on for another live stream.
You
so
bet.
We got to get that in the calendar. And folks, as usual, if you have any additional questions, jump in on Slack. Kim's easily accessible there. And we will be seeing each other soon. Okay.